This module will show you how to perform a simple linear regression. A regression is an extension of a correlation and fits a statistical model to the data in the form of a straight line. It is a way of predicting values of one scale variable, either numeric or continuous, from another scale variable. The regression statistic tests how well the line fits the data. The fit of the regression model is determined by three key components. First, total variability. Second, residual or error variability. And third, model variability. Model regression, which will not be covered here, is when you have multiple predictors of one dependent variable. Linear regression has several key assumptions. First, there's a linear relationship, and we can test this by inspecting a scatter plot. Second, independence, so that there is no or literal multi-collinearity, i.e. the two variables are measuring different things. Third, homoscedasticity, in which residual variance should be similar at each level of the predictor. And fourth, that you have normally distributed errors. So please note that these are errors that we're testing, and it doesn't refer to having normally distributed variables. So before we run linear regression, we're going to graph a scatter plot between our two variables. So in the data set for this module, we've got cups of tea and cognitive function. And what we're wanting to know is, does the number of cups of tea drunk per day affect a person's cognitive function score? So to graph a scatter plot, we come up to Graphs, Chart Builder, click OK. On the left-hand side, we have our scatter dot plot selection to choose from, and just click the top left plain scatter plot and drag and drop this into the gallery chart area. Now we can see that both these variables are scale variables by the ruler that is on the left-hand side. So we know we can put these straight into the graph. So we're going to put the cognitive function onto the y-axis and our number of cups per day, left click, drag and hold, and bring it down to your x-axis. When we have a look at this screen, bear in mind that this is just a preview and uses example data, so this doesn't show you what your actual data would look like. To have a look at your graph, press OK, and the output screen will pop up. Remembering this first section of text tells you what command you've asked SPSS to run. And we now have our scatter plot. So a few questions to consider is, based on the scatter plot, what do you expect the relationship to be like? Do you expect there to be a strong correlation? Where do you think there might be a line of fit? And will that regression line of fit be statistically significant? Once we've completed our scatter plot graph, we can move on to running our actual analysis. To do this, we come up to Analyze. We come down to Regression, and we're going to come across to Linear. In this example, we want to know if the number of cups of tea drunk per day is related to a person's cognitive function score. So in this example, cognitive function score is our dependent variable. It's our outcome variable. So left click and move that to your dependent variable box. Left click on number of cups of tea and move this across to your independent box. As we're unsure what type of relationship to expect, the method default is going to be enter. We then come to the right-hand side of this pop-up screen and select statistics. The default is for estimates and for model fit to be selected. We also need to tick the following boxes. Confidence interval set at 95%. Durbin and Watson. Case-wise diagnostics. R-squared change. Descriptives. Part and partial. Collinearity. And we can change the standard deviations for this example to 2. Once we've set up this screen, click Continue. Under your Plots tab, so the second one down on the right-hand side, we're going to set up our residual plots. So we're going to move the Z residual, which is the third one down the left, across to the y-axis. And we're going to move your Z predicted, which is the second one from the top, across to the x-axis. We're going to tick the boxes for histogram, normal probability plot, and produce all partial plots. And this is going to look at the standardized residuals or errors. Once we've done this, please click Continue. And then on this main screen, click OK. And we're going to have our output pop up. So the first box is our descriptive statistics box. This gives us a summary of the mean and standard deviation, as well as the sample size depicted by n for each variable. So we can see that there's 716 people that had a cognitive function score and 716 people that had number of cups of tea drunk per day recorded. The mean cognitive score was 50.61 with a standard deviation of 9.8, and the number of cups of tea drunk per day was a mean of 3 with a standard deviation of 1.6. A correlations matrix table is then provided below. What we're wanting to have a look at is your correlation being this number here.